What's up, team? Today we're talking about inscribed angles, the relationship with the central angles, and then what the heck is an inscribed quadrilateral. So here we go. Review. In this circle here, we have a central angle. It's here in blue, angle AXB. We talked about those previously. The new stuff in red, angle ACB, that's what we call an inscribed angle. Now, this central angle and this inscribed angle, they both meet at points A and B. That is crucial. The relationship between these two things, here's the new stuff, is that the measure of this red angle, the inscribed angle, is exactly half that of the central angle. So, for example, say that this angle over here is 120 degrees. That means that the inscribed angle is exactly half that angle measure, so it must be 60 degrees. That's going to be true every single time you have a central angle and an inscribed angle that meet at the same points on the circle. Another way to say that is that they intersect the same arc. So in this case, arc AB is the arc that they both intersect, the minor arc specifically. Okay, I want to show you something on Diesmus real quick, and what we're going to see here is really just more of the same. So say we have this circle here. We have a central angle of 62 degrees and then an inscribed angle of 31 degrees. Well, that makes sense. It's exactly half. Something kind of neat about this is if I move this point along the major arc, it's always going to be 31 degrees, no matter where it goes. That's really cool. That's neat. Additionally, if I were to make the central angle a little bit bigger, say I make it up to 90 degrees, notice how the inscribed angle also grows, and it remains exactly half the measure of the other angle. Now, another neat piece of this here, let's get to a number that's a little bit easier to examine. Here we go, right there. Okay. If we move this, we know it stays 40. That's not a surprise. We just explored that. But check out what happens when we cross this barrier and we actually get onto the minor arc itself. It changes. It not only changes direction, but it gets a lot bigger. It goes from 40 degrees to 140 degrees. Notice that 40 and 140, those angles are supplementary to one another because they add up to 180 degrees. That is not a coincidence. That'll be the case every single time that you explore something along these lines. So what I want to check out now is what we call an inscribed quadrilateral. So these two figures here, they have quadrilaterals on the inside. This one's named ABCD. This one is EFGH. And we have a few angle measures. We want to find the other one. So we're really just going to build on that fact that we just explored. So notice that opposite angles here are really just inscribed angles that meet at the same point. So angle A has endpoints at B and D, but so does C. It has endpoints at B and D, but they're on opposite sides of the circle. So they're going to be supplementary to one another, just like that piece that we explored in Diesmus a moment ago. So in this case, if angle D is 80 degrees, that means angle B must be 100 degrees because they add up to 180. They're supplementary. Similarly, 85 plus 95 in this case add up to 180, so those are supplementary as well. So if you ever have an inscribed quadrilateral, you know that opposite angles are always going to be supplementary. Always, always, always. One more for the sake of example. We have EFGH over here. In the same way, I should have chosen different numbers. This isn't very creative of me. But if we have a 95-degree angle, that means its opposite will be 85 degrees, and the opposite of 110 is going to be 70 degrees because those are supplementary to one another. So opposite angles of inscribed quadrilaterals, always, always, always supplementary. They don't have to be a perfect square, a rectangle, a trapezoid, a parallelogram. We do not care the specifics of what that quadrilateral looks like, but we know that opposite angles are always going to be congruent. Okay, inscribed angles, the relationship with central angles, and we have some inscribed quadrilaterals. Let's dive into some practice problems. Let me know if you have questions. You got this.